Hello, Professor. This is my primary research video. My name is Lira Sai Chapala, and this is a summary of my thesis on building and evaluating a lightweight, open-ended serverless framework development for small development terms. Coming to motivation, cloud-based functions as a serverless platforms abstract away serverless management and build records at fine incrementally at small terms suggest with steep learning curves, frame-edge configuration, paradigms that unpredictable cloud start latencies that shows development and degrade, user experience. Coming to framework overview. To tackle these challenges, I designed a lightweight framework that ensures convention over configuration performance, incremental packaging of changing functions, and provides a unfettered abstraction layers across multiple cloud providers. Coming to components, function routine. In this one, like the first one, infrastructure, generator, GOCLI, GitHub. For the second one, GitHub Actions pipeline. For the third one, monitoring and configuration viewer. The solution compresses four modules: a function routine, a metadata driven handler, discovery, and infrastructure generator, a Go based CLI, and emits Terraforms for AWS and Biceps for Azure, a GitHub Actions powered deployment pipeline that latents task packages incrementally and performs blue green rollets and monitoring and configuration system subsystem learning open telemetry locality and Grafana in production. Coming to empirical evaluation, to validate the framework, I ran three evaluations. First, performance, benchmark 100 cloud innovations and AWS Lambda and Azure functions. Plus one starts and the plus one starts Terraforms for AWS, Biceps for Azure. A GitHub Action provides development pipeline that latent packages incrementally and performs blue-green roulets and monitoring and configuration system learning, open telemetry locality and performance Gena in production. To come Coming to frame frame file empirical evaluations, we go to validate a framework. I ran three evaluations. First, performance by benchmark 100 cloud innovations on AWS Lambda and Azure functions plus one starts through under ramp loads. Second, cost simulation, a 24-hour run mimicking 10 million monthly innovations, comparing compute and request fees. Third, a mixed method developer study with five participants complementing three tasks: developing an HTTP functions, configuration and evaluation variable, and searching a trigger using both native tools and my framework. Coming to the key results performance, res- results show that incremental packaging cuts mean cloud start latency by about 30%, for 30% to 480 milliseconds on AWS version, 560 milliseconds on Azure without satisfying warm start through, through, throughput with stayed under 150 milliseconds at up to 150 requests per second. Coming to the key result cost per innovation was comparable around 0.0015 to 0.0016, while AWS granular billing increments offered more predictable monthly charges. Coming to the key result development experience in developer study, test comparison times improved by 35 to 45%. For example, HTTP developments took 45 seconds, version 73 seconds, nativity, and prevailed difficulty dropped from an average rating to 3.4 to 1.8 on 5-point scale. Coming to conclusion and recommendations, embrace convention over configuration. Um, use use incremental packaging, provide clear guidance below. These findings confirms that well-designed abstraction and packaging mm, strategies can deliver both performance and usability gains without hidden cost. I recommend participation, adopt convention over configuration, incremental packaging, and invest in clear error missing for researchers. I suggest explaining adaptive packaging, multi-provider scalability, and security implements. Yeah, this is my primary research video, Professor. That's it.